Hello, hello everyone. So, this is episode number 17. Um, just for those that has lost count, let's say that, of this series. Thanks to Fabio Ciucci for letting me stream his book, basically. I think it's the best book that I've read in relation to how to program the Amiga hardware. And that's why I decided to stream it. And I'm streaming it in English and in Italian, as most of you know. We just did a sprite on the screen and how it is. Just to remind you also, the data, the way sprite is created on the Amiga, I can bring my I can bring my tablet. Where is it? Here. Okay, and remind you, okay, that we have our sprite data, which is consists of, let's say, two planes, okay, but they have before the data we have 4 bytes or 2 words or 1 long word, which is divided as shown below. The first byte is v start, the second byte is h start, the third byte is v stop, and then our special let's say bits that are used for the sprites. When the data is finished, we always finish the sprite with 2 0 words, okay, just to indicate that it's a 0. It's the end of the sprite. So it's two words which are 0. This is also reflected in the book. So if I go to the book, I was saying the sprite data, just to remind you how a sprite is. Okay, same as the diagram, you have the two words, okay, the sprite data and then two zeros. Okay, that's how we ended up last week. I think I scrolled down. Episode 16 ended there. So yeah, that's according to my notes. So we continue from here. Remember that the Amiga has 5 bit planes. Okay, this gives us 32 colors. Okay, index 0 to index 31. The fifth bit plane uses colors from index 16 to index 31. So 16 colors, which these colors also happen to be used with the sprite on the sprites, basically. So this is why you see many games on the Amiga that use 16 colors and not 32 colors. One of the reasons, let's say, because the sprites and the bit plane use the same color, and hence if you put a sprite on a bit plane on an image that is using also those colors, things might not look so great. The other thing is also because the Amiga handling the fifth bit plane slows down drastically. I mean, I'm talking about the custom chips. So these 16 colors that we have are divided into groups of 4. Okay, so we have every 4 because we have 16 colors, so division by 4 we get 4. Every 4 colors are used for every group of them is used for a pair of sprites. So group 0, group 1 uses sprite 0 and sprite 1, is used by sprite 0 and sprite 1. Sprite 2 and sprite 3 uses group 2. Group 3 uses 4 and 5, and group 4 uses 5, 6 and 7. Okay, so this is why, I mean, this is not mentioned in this paragraph in this part of the book, but I'm preparing you basically. And as you can see here, he's mentioning the 4 colors, okay, used for sprite 0 and sprite 1, which is index 16, which is always transparent, okay, then is 17, 18, 19. So index 16, index 20, index 24, and index 28 are always transparent for sprites. Okay, those 4 colors can be used on an image, okay, and they will not affect sprites. So in a way, you have those colors, let's say, if you want to use a 5-bit plane. As you see here is saying run lesson example 1, which I have already done and showed you. I've done that. Here we have our first routine, okay, or first example of how to set the sprite pointers, how to point them to our data. It is the same routine that we use to point the bit plane pointers, but with 2 different things. Okay, the first one is the source, instead of pointing to a bit plane, is pointing to um, sprite data. And the second one, the destination, okay, instead of pointing to the bit plane pointers, is pointing to the sprite pointers. Okay, as you can see here, the first one is where we have our sprite, the second one is where we have our sprite pointers. And then we have our usual move and swap to, remember, because the registers are 16-bit and we are dealing with address registers which are 32-bit, so we need to copy 16 and 16 bits, as in one in the high word and one in the low word. So that's basically it. To view sprites on the screen, you always have to have at least one bit plane. Okay, you cannot view a sprite on the screen without having any bit planes. It is not like what we were doing before, having copper bars, etc. You always need to have a screen to be able to display sprites. You cannot display a sprite without a screen. um, when the bit planes are disabled, there are no sprites basically. A sprite gets hidden, okay, when it is out of the display window start and display window stop. I just remind you what they are, okay. Remember, the screen of the Amiga is, let's say, starts from 00, but we do not see 00. It's outside our visible area, okay, of the screen. It's somewhere outside. Normally it starts at 2C, okay, and 2C81, let's say. That's the default for display window start. However, for a sprite to appear on the screen, it is 2C40. Okay, that's where we see a sprite on the screen. And go to the whiteboard. I should have this image. So this is how big the Amiga screen is, okay, but our monitor can only display, okay, this area, this blue area, okay. It cannot display location 00. It cannot go there, okay. So when a sprite exits the screen, okay, the blue border, okay, you can see it getting exiting the screen. Our window starts at 2C, okay, on the Y, and 40 for, I'm talking about the sprites. So this point, which is always the first top left hand pixel, the first pixel of the sprite, is always the pin. It's always where the sprite, the X and Y coordinates rely on. So if we had to have it here, this would be 2C40. Okay, let's return back to the book. The the thing that I forgot to mention, but we covered it last week, is that right now the Amiga handles the way the X coordinate, coordinates are by default different than the Commodore 64. When you add 1 on the Commodore 64, you move the sprite to the left or right. When you add it, actually it's moving to the right, by 1 pixel. The Amiga moves by 2 pixels, okay, so that 1 byte will cover the whole screen. However, you can enable the sprite to move at 1 pixel intervals, but by default it is 2. Okay, so because of that, okay, we have this formula, okay, which is, if our screen is 320, okay, wide, pixels wide, then half of the screen is 160 to display it in the middle of the screen. Then the 160 needs to divide it by 2, so that becomes 80, and then we add 40, okay, to it, um, which is our X starting position. Okay, the 2C is our Y starting position. Okay, so here he shows a diagram similar to what I just showed you, okay, where 0, 0 is the 2C, 4, 0 where they are, okay, here in this corner, and this is the corner of the sprite, okay, that if we wanted to view it, it will be there. So this part, the part where the hashes are, okay, is non-visible area, okay. The visible area is here, which is white, where we define our display window start and display window stop. In later on we'll see not just how to say use 1 pixel when moving the sprite, okay, and why it is the byte by default is every 2 pixels. We will also see something that in the last episode, in a way, I lied to make things simple for you, okay. That is that a sprite can only be 256 by pixels high. Actually it can be higher than that, but to keep things simple I said it's 255, okay, from 0 to 255, which makes it 256 pixels in a way. In theory it's 255 pixels what you see, because you cannot display 0, but anyway. So the sprite X values, okay, are from 0 to 447, okay. That means we need 2 bytes to be able to cover all the possible locations, okay, that um, we have on okay, that all the, because the window where the sprite is visible is smaller, but to move it from 0 to 447, okay, that means we need 2 bytes, okay. On a normal screen, okay, which is 320 pixels wide, okay, this is from 64 to 383. So here starts at 64, okay, which is 40 hex, and this corner here, okay, is 383, okay. The Y values, okay, starts from 0, okay, as you all know, okay, so this is 0 for the Y, and it goes to 262, okay, which is, sorry, I need to correct myself, um, it is from, so the visible part is from 2C, okay, to 1 to C, okay, which makes it 1 to C makes it I don't know right now in hex, 300 I believe it is. I think 1 to C is 300, yes. So it is from 44, okay, to 300 visible. So we also need 2 bytes to have um, to display the sprite in all positions on the screen, okay. um, it goes beyond the 300. I think it is 312 or 316. I didn't write the number here, but of course, that is not visible, okay? And it's not possible to see, so it will be in this border where the hedges are. Here he's saying it's 300, in fact. I didn't read it. Yeah, he doesn't actually mention also the what is the maximum of the Y, but yeah, it's above 300, it's useless, basically. I don't know if I in my temp in my let me see if I did something while you're still watching the screens, but let me see if I did something in relation to. No, I thought I had written some notes or I did some on the whiteboard, something that makes you um, is more detailed than what there is in the book. I should have done actually. But anyway, I should have come up with all the numbers on a screen, but yeah, comes now to my head. Anyway, so now we have example 7 BC and 7 give me a second. Yeah, we are here. I just want to make sure. Okay, this 7F. Um, did I skip something? I feel I have skipped something today. Yes, I did. I need to explain. I need to explain 7A1. Okay, so let's go back to the Amiga. We need to be on the book, not on the Amiga. So I explained this last time, but I need to explain uh, one thing, because we only did 7A and there is 7A1. Okay, so as you can see here, we have the sprite data. Okay, this part, this is the end of the sprite data, and these are the 4 bytes. Okay, v start, h start, v stop, and the special um, um, bits of this byte that are used for the sprite, which we haven't yet discussed yet. What I want to show, where is it? Yeah, so here we are initializing one bit plane, okay, and here so look at the routines, how similar they are. This is for setting up the bit plane pointer, okay, and this is for setting up the sprite pointer. They are identical. If you see these 3 lines, they are identical, just the source and destination of the routine are different. Okay, that's one thing that I wanted to show. And these are our sprite pointers, and we are using sprite 0, so these 2 pointers, okay, are being updated. Okay, one is the high word and the other one is the low word. Okay, these are the colors of the sprite. He's saying, yeah, this one I need to explain better, and luckily I saw it. So the v-stop, it is 3D here, okay? But how did we arrive to 3D? Remember, so a sprite, we tell the sprite where it starts, okay? We don't specify the height of the sprite, but where it stops, okay? So if our sprite is 13 pixels high, we do 30, okay? That is where it is on the Y position, okay? And we add 13, which is OD. So the real result is 3D, okay? That's how we specify the sprite, because some people might confuse it and say, okay, our sprite is 13 pixels high, so we write 13 there, or OD, but actually we need to write 13 plus where it started. So that's why it's called v-stop. It's not called height, it's called v-stop. So let's see my notes if I'm missing. Come on. If I'm missing anything which I didn't say. So this one is, so here he's saying 0, 0 is outside of the screen. Basically 2C 4O is where we see our first position. Basically it's a repetition of what's there in the book, so I'm not going to go into the detail of it. Okay, so now that I explained how the x coordinate works and how the y coordinates works, if we want to position it in the middle of the screen, okay, not at the top of the screen as it is, okay, what do you think the coordinates needs to be? Okay, and this is obvious in a way, okay, and he mentioned it here. So the middle of the screen is 160 and we add 40 to it, and in theory, okay, and the for the x, and for the y it is 2c plus 128, because the screen is height is 256, middle of it is 128, so we know that it starts at 2c, so 2c plus 128 is our middle screen. Remember, this is hex, this is decimal, okay, just not to confuse, and this is hex and this is decimal also, okay. So because of what I said about the h star, that is every 2 pixels, the 160 needs to be divided by 2, okay, so we end up in the middle of the screen. So if we want it, sorry, in the middle of the x coordinate, if we want it to be in the middle of the screen, okay, then we have to divide this, the 160 by 2, as I said, and leave the 128, which is the height, half of the height of the screen. That, I mean, the y coordinate is not division by 2, it's always by 1 pixel, so we leave it the same. For that, we have an example. Okay, we go on the Amiga. So 7A1, if we assemble it, you will see it in the middle of the screen. What changed is, okay, and I'm going to show it to you in the code. On the Amiga. So as you see, this is our start Y position, okay, 2C plus 128, okay, and I'm just going to continue on the Y. So V stop is to C plus 128 plus OD, which is the height of our sprite. That is how to tell it where it ends. Okay. Here we have the X position, which I explained is 40 plus 160 division by 2. Okay, to have it in the middle of the screen. So we go back to the book. This one. So he says to move right now as things stands, okay, to move the sprite in the X position, okay, we only need to work on 1 byte. But to move the sprite in the Y direction, we need to move it, we need to update 2 bytes, okay. That is because we have the V start and V stop, so that is 2 bytes to specify where our sprite is. So that was 7a, the example. We need to do till 7d basically. This oh, actually let me show it to you first to see what it does. So this one, okay, if I press the left mouse button, the sprite moves. It's moving every 2 pixels, remember. It's not moving every 1 pixel. Okay, that is our first example, and that is what the book talks about. So let's go to the book. Oh, sorry guys, I left you in the book, so I need to do this again. Assemble J. If I press the left mouse button, you see it moving. If I press it more, it's going to be hidden, but yeah. That is the sprite moving on the to the left of the screen. Okay. The book showed you the sprite moving to the left, and I'm going to show you the code now, or we're going to go through the code to see what it's doing. So as always, this is the part that is common. I explained it 1,000,000 times. I do not need to go through it. Here is our routine, which is called move sprite. Okay, this is the routine that is moving the sprite. It's a very simple one. Okay, and you're going to be amazed. Okay, we are moving it in the X direction, so we are just adding 1, okay, to the H start. Remember, H start, okay, is I have marked this wrongly. It should be this one. Okay, we are adding 1 to the value in the place where I have highlighted or marked right now, not on V start. Okay, so every time we add 1, remember we're moving 2 pixels, not 1 pixel. Every time we add 1, it seems strange, but that's by default. Okay, the rest doesn't change. Okay, that's where our code ends. What comes next I will explain in a minute. So that is all. Okay, it's a very simple routine. My god, it cannot be more simple than that. Adding 1 and returning back to the sprite. So that is our first routine. However, then he comes up with a series of routines, which I am going to show you. Okay, if we want to move it to the left instead of to the right, we do sub 1. No. If we want to move it in the y direction, okay, we add 1 to the v start and we add 1 to the v stop. Okay, if we're moving it down. If we are moving up, okay, we add 1, sorry, we subtract 1 to v start and subtract 1 to v stop. This is why he said when we are working on the x horizontal, okay, we only need to update 1 byte. But when we are working on the vertical, okay, we have to work on 2 bytes. Eventually, you're going to see that in a way it's always 2 bytes. But anyway, that comes later, because I think it's after 7e, which we will not even arrive there. But anyway, so that is going up. Now to move it diagonal, okay, diagonal to the going down and right, we add 1 to h start, we add 1 to v start, and we add 1 to v stop. To move down, to move down but to the left, not to the right, okay, we subtract 1 to h start and add 1 to v start and v stop. We continue to add the to move it up, okay, and to the right diagonal, okay, we add 1 to h start and subtract 1 to v start and v stop. The opposite way around, when we are moving up and diagonal to the left, so left, okay, we subtract 1 to h start, subtract 1 to v start, and subtract 1 to v stop. Okay, so it's common sense, and all these I'm going to show them to you. If I switch you to the Amiga also, so this is going to move now to the right, to the left, okay, and remember it's moving 2 pixels. This is going to move down, I believe. Yeah, and you can see it's more smoother moving in the y direction than moving in the x direction. This is going to move up. It's going to go out of the screen, but you can see it moving it up. And now we start the diagonal ones. Okay, that's 1 going down and to the right. Down and to the left. This is up and to the right, I believe. Yeah, it will vanish soon, so yeah. And this is up and to the left. Okay, and I believe I did an extra one, which is crazy me. Yeah, it goes at a different slope. Okay, instead of -1, I mean, I forgot what I did. but I can show you. There you go. I'm subtracting 3 instead of 1. Okay, that's what I'm doing. That's why it moved at a, let's say, not an angle of 45 degrees. Okay, back to the book. You are on the book, and I have to be on the book. So actually, it's not me. I said it's me. Actually, also he gave it as an example. I thought I did it, but actually it's also an example there. Now we're going to do 7C, the theory book, okay? Because this is the example book, and this is the theory book. The theory book says we need to do that. Let me see. We need to do 7C and 7D, and then we arrive at 7E, but we will not do that. I cover. I still feel I missed something from yesterday, from last week. This I covered it. Somehow yesterday I felt I spoke more, or I talked more than normal. Anyway, let's continue with 7C. Yeah. Okay, so here is why 7E is I cannot really start 7E. Here you can see the sprite, like when it reaches the edge of the screen, it bounces. Okay. Now he is not using a routine that calculates these bounces, okay? But he's using a table. He generated a table for the x values, okay? Remember, we have a byte for the x and we have a byte for the y. So he generated a table for the x, okay? And he's reading the values of this table, okay? And basically reading it, and once we reading it, he's positioning the sprite according to the values that he got, and then when he finished the table, he restarts again. Now the tables were generated with the assembler, okay? However, there are two commands that let you generate the tables. Okay, this is a quick overview of what I need to cover in 7E. Basically, there are two commands that generate the tables, okay? One is you can generate the table and you see it as source data in your source, and the other one you can generate it and save it as binary file in your floppy, okay? And then include bin, okay, using the assembly directory of include bin to actually read the data. The um, the commands that do this, okay, use the famous sine and cosine to generate the data, okay? So we will need to cover also these things, and that's why 7E I cannot do it half of it. Plus, and I can tell you that in advance, okay, 7E in the PDF is corrupted in terms of I'm going to show you. First of all, you didn't see the example, okay? You didn't see the Amiga running the example yet. That is what 7C generates, and that bounce effect is being read from a table, okay? Which was generated, as I said, with a command in the assembler, which uses sine and cosine. So that's one thing. The second thing is I'm going to show you the book. I'm going to jump to 7E quickly, okay? So that you understand where I'm coming from. So 7E. Okay, so 7E is 14 pages long, okay? The example and all the data here, because he literally wrote another chapter in relation to this, okay? So from here onwards, okay, is another chapter, okay? And he's explaining how the data is generated in the tables. But these diagrams that he has are corrupted, okay? So I tried to, let's say, restore them, which I did manage, but it took me a long time. I tell you, I spent 1 week to get exactly, I mean, 1 week, not full time, of course. Every time I get a minute, I was doing this. And you can see that the images gets corrupted and they do not make sense what he's trying to explain. And this continues on and on, okay? And then they even get corrupted in this part where he is explaining the parameters that you need to enter in for the commands, okay? Luckily, and this I discovered after I've been wasting my time trying to fix them. Luckily for you guys and for us all, okay, the sources on the disk, the source 7E, okay, is not corrupted. You will see that they make sense, okay? Diagrams work. But there's still a heavy explanation into this. So this is why he explains how the tables are generated, and I wanted to show you that. So let's go back to 7C. And let's see that I have everything fine. Okay, so you can see this is reading values for the X. We are only changing the X values. The Y is always the same value. For the sprite is from a table. And that is, so I showed you the book. Oh God, I showed you the book, but you didn't see the source as I, so sometimes I do talk on my own because I did it too many times. So let me switch to the Amiga. Here is the source, okay? 7E. And you can see, okay, that the diagrams are not corrupted here now. Okay? So here where he defines what parameters you have to enter to create certain patterns are not corrupted. And this is the type of data that we will generate or is generated. So let's load again 7C. And just to remind you and show you, this is being done from a table. Generated from a table, so which I will explain just right now. You can see the text of the book properly, right? I hope so. I mean, I've never changed the font, but I don't think I can, to be honest. I not make it bigger, or if I make it bigger, then I will lose focus. Ah, ciao Dario. So, the routine that is reading from a table, okay? So, first of all, we're doing 7B. 7C, I don't know why I selected 7B. Anyway, so this is the routine, always the same routine, movie sprite that we are calling, okay? And here is the routine. Now, I'm going to simplify it. Ignore what's happening up here for now, okay? And just see this part, okay? Before we had add one, okay, into H start, okay? Now, instead of adding one, we're getting a value from a table, okay, which is pointed to by 80, and we are moving it into H start, okay? The value is coming from this table, okay, that was generated, which I will explain in 7E, as I said. And we are just, every frame, we are just reading one value at a time, okay? There are 200 of them, okay? And setting the X value, the X coordinate according to these values, okay? The Y coordinate remains the same. What does this routine do? Well, it's simple. It's getting the start of the table, the end of the table, checking that has we arrived at the end of the table. If we did, we restart again. So here, the compare, okay, fine, fine, or fine in English, of the table X, okay, so -1, so fine table X is here, okay, -1. If we arrived here, okay, we know we need to reset our start again the table from the beginning, and that's what we do. We load table X -1 into table X point, okay, which is, as you can see in the init part. That's basically it. That's how simple it is. So I did not want to confuse you, because this part is exactly the same as the previous, just the instruction changed. And this is how we are cycling through the table and reading the values one by one. Nothing else, Okay, and this time I marked H start properly, because before I had V start marked for some reason. Anyway, so this is the value that we are changing every time the sprite is moving, and this table creates that effect that when it hits the border of our screen, it jumps back. Okay, because of that, Fabio gave us some more examples which I'm going to show. So we jump back to the Amiga. You can see it bouncing. I don't, because I haven't jumped back to the Amiga. And we read 7C1. Okay, and we execute it. This is a different type of bounce. Okay, you can see that instead of on the left hand side where it was bouncing, now we are doing it on the right hand side, the bounce. Just a different table. The Y is not changing, we just changing the X. Also, the sprite might not look so smooth because, as I said, we are moving every 2 pixels, not every 1 pixels. We will be talking about the special byte for the sprite, the number 4, okay, from the special from the 4 bytes that define a sprite later on. That was one example. And this is another one. This is more like a spring, goes on one side, then goes on the other side. And you know, just, let's say, bouncing on both sides, if you want to call it like that. But it's always reading from a table that was generated with the 2 commands that the assembler provides. Okay, so I believe we finished 7C. Yes, and we can do 7D. So 7D is the opposite of what we did. This time we're using the table to move the sprite in the Y. See it jumping, okay, when it hits a certain position, but the X remains constant. Okay, we will jump to the book and go to the source. So it starts here. I marked it, but there's nothing to say there. This is our routine, okay, and then this is the routine that is updating. Notice we are updating V start and V stop. Before, remember, we were when we were changing the X, okay, the value of the X coordinate for the sprite, we were only updating H start, which is only 1 byte. But for moving in the Y direction, we need to update 2 bytes, which is V start and V stop. This part is the same thing, reading to the table, and when we finished, we start again from the beginning, okay? And we read, of course, the value that we need, and we move that value into VStop. Then we know the height of our sprite, which is 13. We add that, and we move the value of that into VStop. That's the only difference from doing the calculation for H start, okay, where we had H start. So this part is working on 2 bytes while A start is working on 1 byte. The table is here. I didn't mark it. I mean, it's same table but used on the Y. Okay, and everything remains the same. And he also gives us more tables to read, which if we jump back to the Amiga, you guys are on the Amiga, I'm not. This is a different pattern. It's more like a spring bouncing on both sides, and nothing changes. So still the same part. First of all, I want to go, before I mention it, I want to go to the whiteboard. Yesterday, for some reason, I drew a lot more and I explained a lot more certain things, which makes me think that I'm missing something. But I mean, these are for example 7e, so I know that those are fine. But these two, okay, this one, okay, I was explaining the sprites and how they are, let's say, married together or joined together for the colors. Okay, so we have a sprites, we have 16 colors that start from index number 16, and we have sprite 0 and sprite 1, hence they use these colors 16 to 19. But remember, this column 16, 20, 24, 28 is always transparent. Okay, then we have 2 and 3, 4 and 5, 7, 6 and 7. They all use the same colors in these groups. Okay, later on we also can talk about attached sprites, and attached sprites means that you can attach sprites together to create 16 colors. Okay, so the Amiga has another mode of the sprites. A sprite can have 16 colors, but then you don't have 8 sprites, but you have 4 sprites, of course. But yeah, that was one of the diagrams that I drew yesterday. And this one, okay, I did show this, but maybe this shows it better, where outside of our normal screen, this is what we can see on our screen, the green part, but the screen actually starts from 0, 0, okay, and ends in theory, okay, not really, at 512, 0, okay, and same on the Y, okay, which is 512, 512. That should not be 256. That's a mistake. 512, 512. That's in theory, but actually it's not that long. Okay, but to make you aware that in the X and in the Y, we both use 2 bytes in a way. This is what I forgot to explain. Okay, I knew I was missing something, and somehow going through the notes, I'm showing it now. So our horizontal move of the sprite, I said it moves every 2 pixels. But in theory, we need 9 bits to move it across, okay, from here to here, okay, even though we have this window that is visible, okay, but in theory we need 9 bits. The Amiga by default uses the 8 high bits, let's say, and ignores, okay, ignores the lowest bit. That's why we move every 2 pixels. Okay, this 1 bit, okay, is in the special is actually in bit 0 okay, I can say that, isn't actually in bit 0 of the special byte. Guys, I'm going to change this because it's annoying me. That's a real big mistake. I need to change the pen. That's 512 by 512, not 512 by 256. It's really annoying me being like that. So So that's why we are moving every 2 pixels. Once we enable this bit, okay, we need to enable it on and off depending whether we are even or odd. So the value of the when we are moving is even or odd. We will be enabling this on and off, and that is our 9-bit on the H. By moving the sprite in the X, let's say coordinate. Okay, so that was one of the things that I missed. As you can see, okay, I even gave an example here, okay, that we have 0, 0, 0, 1, 1, 1, 1, but this one is always 2 pixels, okay. That's basically it. So those were the notes that I added yesterday while doing the stream. These are my notes for 7E, because we will also be covering in 7E, I forgot to mention this, 3 instructions. One of them we mentioned it, but very little, which is bit test, okay, BTST. Then there is bit set, okay, BSET, and then there is oh god, right now I forgot the other one. ah, bit clear, okay, BCLR. Okay, so there are 3 instructions that we will be covering also of the 68,000, which we haven't really covered, or we mentioned them little. So that's the other thing. Let's go back to the book. For those, because next week I will be covering these instructions, but also we'll be covering the special bits. So just to show you something, the Amiga hardware manual, which is the second Bible after this book, okay, that you need this book. Page. Sprites. So let me find it for you, because this is what I need to show you. These are my notes, by the way. The ones that you're seeing highlighted are my notes. There you go. Let's make it big. The 4th byte, okay, which is called the sprite control. Bit 0 is for H start, and then vstart and vstop also has bit 1 and bit 2. Okay, the other bits are not used, and bit 7 is for attach sprites. I will be covering all these basically. Um, um, Ozzy, I missed your messages, but I'm going to read them. Yes, of course. Yeah, but what I meant is, Ozzy, the instructions that I'm going to cover is what I'm following the book now. So, yeah, uh, it's what we are going to cover because the book left them basically for this chapter um, to, you know, when I was explaining the 68,000, we didn't cover every instruction, but we went those that were basic. Those that, let's say, he considered more advanced, they come bit by bit in the book. For those that do not know, Ozzy mentioned AMMX. This is extra instructions that has been added to the vampire. Okay, remember the vampire uses the 68080, or what they call it, 68080. Okay, Ozzy, you can correct me on this. This is your subject, not my subject, so you know better than me on this. And yes, they added more instructions in the, let's say, new version of the 68,000 for the vampire. So yes, and I agree with Ozzy also. The information about these instructions, you can find them everywhere. Um, yeah, Apollo, that's how they call it, Apollo 68080 instead of, 68080. Okay, so it's the Apollo 68080. Okay, just to, thanks for the correction because I didn't know exactly what they call it. I know it is 68080, but yeah. So that is the modern new version of the Amiga CPU, let's say, that is used in the Vampire. Yeah, there is no Motorola. It's an FPGA implementation of the 68,000 plus these instructions. So yeah. Anyway, we will be covering these next week. Hopefully, I managed to finish 7E. 7E requires quite a bit of time, and I'm giving it a stream on its own. As you will be noticing, also, this chapter has got 30 pages, so do not expect it to be finished with 2 streams as we were doing, or 3 streams as we were doing with the others. It will take quite a number of streams to finish the chapter of sprites. Also, after this one, this is the chapter that I consider in the book of Fabio, okay, where there should have been a divider between beginner section, okay, and advanced section. From chapter 8 onwards, the advanced section of the book starts. Okay, we will be going. The next chapter goes into certain aspects of the Amiga hardware, like DMA and all, and interrupts and all that stuff. So and then there are 2 whole chapters dedicated to the blitter, okay, which I believe is 60 pages in total or 50 pages in total, and that makes it quite a long chapter by itself. I mean, there are 2 chapters actually, but that's from after this chapter, things starts to be longer and more. There are more examples. So do not expect, to cover things as quickly as you thought. In fact, we are page 80 of this book, and the book has 400 pages. So there are only 16 chapters in the book, if I remember correctly, or 17. So if we've done till chapter 7, that means the next 10 needs to be divided by from what remains from this one. No, so they are quite long chapters. We will stop here. Okay, so first of all, thank you very much, guys. Thank you for everything. Thank you for all the encouragements. See you next Sunday, and I hope you enjoyed the stream. Cheers. Thank you. Bye bye.